Hi everyone. Let's take a look at number 18 on page 378. The vector A is a unit vector and the vector B is any other non-zero vector if vector C equals to, open bracket, vector B dotted into vector A, close bracket, times vector A, and vector D equals to vector B minus vector C. Prove that vector D dotted into vector A equals to 0. Step number one, I'm going to copy down the given vector C equals to vector B dotted into vector A in brackets multiply by vector A. Now here's the key concept, and this is not something that you will do immediately. This may take a little bit of practice, but think about the following concept, right? Our goal is to make sure we can show or we can prove that the vectors DNA, so vector D, dotted to vector A equals to 0. So the hint here is we're looking at the given and we need to figure out what we can do to isolate for vector D dotted to vector A. Now, while you're doing this, you're also thinking about all these other givens. So for example, we know that vector D equals to vector B minus vector C. So that's one idea to give you to isolate for vector D, because we need that in order to have vector D dotted to vector A. Another idea is to recognize, oh, vector A is a unit vector. So this means as we're doing this, somewhere, if you take the vector A dotted to itself, that's going to be 1. So again, I'll say it one more time. Don't want to go straight into this. Our goal is to isolate for vector D dotted to vector A, which we don't have yet. So that's something you want to think about. While you're doing this, we have to use the other parts in the given. For example, vector A is a unit vector, so when you dot vector A to itself, that's going to be 1. And think about the fact that vector D equals to vector B minus vector C. Again, here we go. Step number 2. So what I'm going to do is I'm going to look at both sides and do the following. So I'm going to copy the left, copy the right, and I'm going to take the dot product of each side with respect to A. Now, there are two ideas I want to think about, why and how, right? So everything I'm doing, I'm trying to get closer to identifying where I can get vector D dotted to vector A. And I'm doing this because if you really look at it, the left-hand side, that's going to be vector C dotted to vector A. And on the right-hand side, I can just rewrite this, right, in terms of vector B dotted to vector A, which is a scalar outcome, by the way. And I could put some brackets here, which is basically vector A dotted to vector A. Now, again, let's go back to the thought process. I know from the given, and I'll highlight this for you, A is a unit vector. So when you dot any vector to itself where the vector is a unit vector, that's going to be exactly 1. So this equals to 1. Step number 3. Remember, our goal is to write vector D dotted to vector A. And right now, if you look at this, we don't have vector D, but we can create this simply by going back to the given and looking at the fact that vector D equals to vector B minus vector C. Now, how do we go from here to the next line? You can isolate for vector B. So again, let's write this down on the side for you. Here, since we know vector D equals to vector B minus vector C, I could say vector B equals to vector D plus vector C. I'll put a box around this. I'll put a box around this, and I'm going to plug it in right now. This means on the left-hand side is going to be vector C dotted to vector A. On the right, that's going to be vector D plus vector C in brackets dotted into vector A. Step number 4. I'm going to copy the left-hand side, which is basically the dot product of vector C and vector A. On the right-hand side, I want to expand. So again, I'll draw the arrows. Let's make sure no one's left behind. I'm basically expanding. So this is going to be vector D dotted to vector A plus vector C dotted to vector A. Again, remember, we began with the end in mind, and we reversed engineer. So we want basically vector D dotted to vector A, we have that now. And look what happens. On both the left and the right-hand side, we have vector C dotted into vector A. So this basically becomes 0 by subtracting both sides by vector C dotted to vector A. And now you can rewrite it in reverse, which means therefore vector D dotted to vector A equals to exactly 0. I hope this makes sense.